So, yeah, good morning, everybody. I know it's the last day and the first talk, and I hope you had some coffee. So, let's go. I want to talk about monolithic applications that everybody has or had or wants to have, but not so much about code. So if you want to see code, that's the wrong talk. It's more about if you have a monolith, but you don't want to have a monolith, this is your talk. Here we go. So, two promises. First of all, I want to kill them. Second, I want to help you getting them killed by convincing your managers. But I can already tell you I will only resolve one of those two promises. The other one, not. So, what's the plan? You can see I want to start by a real technical what's actually a monolith, and then we go from there. What's the problem with them? How do I keep people to solve that problem? And so on and so forth. So let me start with a real technical what is actually a monolith, because I love starting by definitions. So, I quoted someone that probably everybody knows, and that's Martin Fowler. You can always get a good quote from him. So we start by the quote of what is a monolith. A monolith is a single logical application. Yeah, executable actually. Yeah, makes sense. Totally makes sense, but actually doesn't help me at all. That's why I continue to read what's actually a monolith. Now you get a bit more details, same article. Any changes to the system involve building and deploying a new version of the application. Yeah, okay, now I get it. That's usually what people are talking about if they talk about monolithic applications. But here's my problem with that. Actually, every application is a monolith by that definition. You cannot have any application that is not a monolithic application because it was always a logical executable. How do you want to do that? So if I said I want to kill that monolith, I actually just have to delete the application because there's no other way. Here's the first answer: we cannot kill or whatever the monolith, no chance. The only chance is we tell our business, no, don't do that business. That's also fine, we can do that. But then we probably don't have a job, and we need a new job, and so on. And now we can discuss if capitalism is cool, but as long as we have it, we need money and we need a job. So just killing it is probably not the answer. What else is going on? Obviously, what people usually talk about is not just killing an application, it's splitting it into parts. That's what people actually talk about. I went by the definition, but usually you talk about splitting it. I still don't like the definition, because if you split an application, you have two logical executables, and going by the definition, then you have two monolithic applications. Unsolvable, that's why I brought another quote. Still Martin Fowler, still the same articles actually. So, I was wrong with the definition. The term has actually been in use by the Unix community for some time, and it appears in the art of Unix programming to describe systems that get too big. Here we go. That's actually where we go. That's what usually people talk about if they have a problem with a monolithic application. It's not that you have an executable, that's fine. It feels awkward because it's too big. Okay, now we can start talking about what actually means too big, and why there's a problem with too big. We have too big means obviously there is something of a size dimension on that thing. And there's problems, because if there wouldn't be problems, we wouldn't need to talk here. So this is my personal perception graph. It's not something with science behind it. If the application is huge, you have a huge amount of problems. You see it on the right side. If the application is nice and small, it's your island of dreams somewhere in the middle. That's where every developer wants to live. But if your application is split into super small parts, you also get problems left side. So not always cutting it smaller is the answer. This graph somehow describes, don't go into nanoservices and super small stuff, you get other problems out of that. Usually the sweetest spot is in the middle. And yeah, I said it's not scientific because I cannot put any numbers on that graph. This is a gut feeling that probably everybody has, but nobody can put a number of where exactly is it big or too big. But what I want to help you with in the next few minutes is finding a few arguments of when it is too big or too many problems or too small. And for that, I actually don't want to look that much on our beautiful island. I want to look at the sharks around that island, describing the problems. We go by 3 sharks from the right side, and later on I will also find some on the left side. So the first one we have is, there's one about ownership. What do I mean with that? If you had a huge application, I believe you most of the time have problems with code ownership and business ownership. You don't have to have that problem, but most of the time you have. What do I mean? It's super hard to have somebody feeling responsible for a huge application overall. Meaning, like, if that thing is super big, nobody understands everything and nobody feels responsible for the overall running system. Usually you have people in teams feeling responsible for their small part, and if you're lucky, that overlapping, overall you have some kind of ownership, but nobody feels responsible for the overall system. So what you get out of that is you get some areas where nobody feels responsible or nobody even understands those areas. So there's a problem with ownership on a huge application. I mean technical ownership, but also business ownership. Usually you also at some point you get code where actually nobody knows why it's existing. Because it happened 5 years ago that somebody wrote that and nobody understands it. And nobody dares to ask why it exists, because probably there's a good reason, but you don't know whom to ask. So there are problems if the code is huge. Another thing is, if that code is huge, you're not autonomous in your decision. Because if there are 50 people working on the same artifact and you want to, for example, change the build tool, you have to talk to 50 people. That's not what I would describe as code ownership. You cannot do your own decisions anymore. Plus, you're actually also bound to business processes. You cannot do your own stuff on that huge thing. Next problem is the build and deploy time. I mean, build time is obvious. If the code gets bigger, usually the build time gets bigger. You can spend a lot of work to avoid that. There are tools that you can still run your small part of the application in seconds, but it's harder than if you have a small application, obviously. Same with build time. You can spend a lot of work and complexity to get the build time down, but most people don't do it. So, for example, the last monolith I worked on, it was perceived as normal that 45 minutes are taken to get the tests running, plus you actually need an hour to build that thing, and that was, yeah, that's how it is. And nobody really questioned it anymore. And if you come with another application that takes a minute, yeah, that's nice, but it's impossible with the application. It's not impossible, but it's too hard, so usually you have a problem with your build and deploy time. What's the result out of this build and deploy time thingy for me? If you go into test-driven working, it's hard to do that. If your tests take half an hour, you do not work test-driven. Nobody does that. Nobody writes a test, waits half an hour, and then sees it's red and fixes it. That's not the reality. So you work other way around. You work like, okay, I code my stuff, I know what I'm doing, in the end I wait for my green tests. That's different. And you cannot go for a style of test-driven or small iterations. Also, what I mean with small iteration, also you cannot iterate small business-wise. Okay, I try that feature, I put it to the customer, I wait for the results. Okay, to putting it to the customer, it takes 1 day to build it, 1 day to deploy it, 2 days to get the log files somewhere. In the meantime, I do something else. Next week, yeah, we would have to check for the results. No, not important anymore. Let's just keep on doing something else. That's what I've seen. So actually, also business-wise, you don't iterate. You just build the whole thing, ship it, and forget it. Just because that's what's happening if you have a huge application, not because somebody wants to do something bad. So just People optimize for their workflow. Last problem I see, scalability. A lot of times that's the argument that people bring against monolithic applications, like you cannot scale it technically. If my database has a load problem, I cannot just put another instance next to it. For the small part that has a load problem, I would have to replicate the whole thing. True, that's often happening. Also true that if you scale the whole thing, it's more expensive than scaling a whole part. In my perception, it's actually not the biggest shark out of that stuff, but it's one of the arguments you have sometimes. So why did I bring all three of those arguments? I have the feeling that the last one, that's the one I don't like working in monoliths, is not an argument somebody listens to. Yeah, okay, that's your gut feeling, you don't like it, your problem. But if you go for, I have a business problem with understanding our domain, some people might start to listen, like product people or business people. If I go for, I cannot iterate as all you agile people want because my code does not allow me, other people might start to listen to you. It might work. And the scaling argument is probably most on the operational side. If your problem is there, people might be interested in getting that thing to scale without scaling the whole application. But yeah. Well, my perception, nobody cares about I don't like it, but some people care about those arguments because there's business behind it and there's money behind those arguments. And if they can spend less money, that's interesting. Making you happy, only if you leave the company otherwise. So what we did now is I showed what I believe are the problems on the right side. And I said there's also the left side of the graph, so I don't want to ignore that part, because if I would, it would look like I'm against monolithic applications. I'm not. I'm only against them if you have a problem with them. But don't always go to the left side, because then you get other problems, and that's not better. That's just different. So I want to at least mention also the left side, so you can have your own arguments where your sweet spot might be. Left side, I believe it's less problems you get, but you still get them. So we start with the first one. That's the computation part. If you have really small deployables, meaning like super small serverless functions, this is something that is getting interesting. Let me describe it like that. If you have, for example, Java code running and doing just calculating stuff, that will always be faster than doing a network call to asking another service to calculate half of it and getting the network back. So whenever network between services involved, you have some kind of slowdown. It might actually make you slower to cut your stuff too small. It's not so much of a problem if you talk about one application of 10 million lines of code, splitting it into 1 million or like 10 parts. But if you're talking about splitting it into 1,000 parts, this is getting your next problem. And there's something else that I didn't think about when I was first totally against monolithic applications, but now I had that problem a lot of time, so now I'm thinking about that part. And that is, it's harder to get independent change if you have too small applications somewhere. It's easier if you have bigger ones. So what I'm talking about is you have a feature, you wanted to build features that touch more than one service. How do you do that? If you start to have to orchestrate deployment, and so first working in multiple applications, then deploying multiple applications. If you're touching the boundaries of the application, you also have to orchestrate, like, okay, first I add the feature on the one side, then I adjust the other side, then I remove the first side, and then I have to clean up the other side again. So it's actually not getting easier, it's just getting different. So especially if you start having ownership shared between teams and applications, this is getting an issue. It's probably worth it if you do a proper cut of your applications into proper sized things. But if you're just cutting it because you want to cut it, this might happen. Now back to my island picture. I believe it's the last time that I show it, so fine. We know the goal now. We want to get in the middle, and we know like 5 sharks to avoid on the right and the left side. My question now, and that's the second part of the talk, is how do I convince the crew? Because we as IT people, we have our perception of where we want to go. But to do all that stuff, we have to convince other people. And what usually happens is this question, and that's a fair question. It's a business question. Why should I invest money in your request for change? It's super expensive to destroy monoliths if you spend months in time of team and don't work on other stuff. So when is it actually worth it? And I've heard that question, and the first time I did not have any answer, so that was the end of the discussion. And what I want to do in the second part is I want to try to help you if you have the same problem, people asking, why should we? Because actually what usually business people want to do is reach short-term goals. Most of the time earning money. Fine, fair. And okay, half of a year I need to destroy my application and rewrite everything and don't win anything short-term. That doesn't sound like earning money, so why? Get it. Where I would like to go in the second part is into the DORA metrics and into this book. So the book is called Accelerate. I believe it's quite famous. Nicole Forsgren, Jess Humble, and Gene Kim wrote that book. It's a book about the Google Cloud DevOps Research and Assessment Center and what they did. They brought out some studies. I believe they started 2017, and since then, every year you got new papers published from them. And the quote on the right side probably explains why I believe that that book is helpful. And the quote is, we found where code deployments are most painful, you'll find the poorest software delivery performance, organizational performance, and culture. And that's interesting because, yeah, software delivery performance, that's something IT people talk about, but where code deployments are most painful, you find the worst organizational performance. That means you don't earn money. And now it's getting interesting for other people as well. Culture, okay. I believe the second part is the most interesting. What did that book do? And what did the studies do? They have research of multiple thousand companies and how they do their operation systems. And they found correlations between the metrics I want to show you in a minute and their business performance. So what they can state out of it is, if you have proper running operational systems, you will probably have better business performance. There's no causation in between, like because of your better deployment you have, but there's correlation in between, and that's probably enough. You can find all the studies in the book. I don't show graphs out of the book, but I will show you the metrics and how you can use them as arguments. So here we go, that's the DORA metrics. It's 4 of them. I believe they are quite self-explaining, but I will go through them for you in a second. So first one, deployment frequency. I believe everybody understands that. So how often do you release to production? In those studies, the worst companies are like every half a year, and the best are like multiple times a day. And now you can ask yourself where you are in the middle. I hope more on the multiple times per day, or maybe at least once a day, and not every half a year, but please think for yourself. Next part is the lead time for changes. I believe that's more relevant, that how long does it take a commit to get into production? Not how long does it take a ready branch, but from first committing code to getting it live to the customer, how long does it take you? Once again, the best answer if you are on the same day, but there are also people around in the same year. So ask yourself. If you go for those two metrics, you can easily optimize for them by just pushing everything to production all the time. That's why there's a third metric, and that's more or less the health metric here, the change failure rate. How often do your deployments cause a failure in production? So don't just deploy everything. It should still be high quality, obviously, but it's also about how good is your test coverage and how good are you preventing at failures. And the last one is, if things went south, how long does it take you to recover? Once again, the worst are at days and weeks. But what about, okay, 5 minutes should be the best answer? Something like that. If your service crashes in production, how long does it take you? Are you able to recover every service in production at all? So it's DevOps metrics, it's about operational systems for sure. But I'm fine with those metrics. I get it why they chose them, and I believe they are helpful because, yeah, they're really describing real problems. So the next part I would like to do, why did I bring the metrics and the sharks? I believe they correlate. So you can use the arguments from the first part of the talk to now have a look at which the metrics they influence, so it works together. So let's go with the deployment frequency. And for that, I believe the build and deploy time is your best argument. Looks obvious. First of all, yes, if the build time goes up, the deploy time goes up. That's the easiest correlation I can bring you. But where it's getting more interesting now, if your deploy time goes up, what happens in reality? It takes longer to build that thing, so what do I do as a developer? I start something else in the middle. I don't sit there and wait for 20 minutes. I do something else. And then I forget to look at my screen, and then I don't hit that deploy button, and so on and so on. So actually less deployments happen if the build time goes up. If the deploy time, really like how long does it take to deploy, goes up, what I've seen is usually you start to bundle your deployments. Hey guy on the next desk, you also want to deploy stuff, I can manage both of them. Just give me 10 minutes, you don't have to care. That's totally fine, that's totally fair because you spend less time. But what also happens here is actually the code takes longer to get to production. And if you made a mistake, you will find out later. Even worse way of this, if you have a lot of people working on it, usually you start to have scheduled deployments like that code gets deployed every morning. So if you build a feature at 11, you have to wait till the next morning. Then everything gets deployed because deployment is so awful. So your deployment frequency goes down and because your build time went up, actually. You will see yeah, sometimes I forget that there are animations, sorry. More or less the same arguments come together if you have a look at the build time and the lead time for changes, because the frequency and the lead time for changes are related, but even more is happening. So if you go for the build and deploy time once again, I mentioned it in the beginning, if it's awful to deploy your stuff, you don't do it that often, means you code more till you deploy. If it takes you long to deploy stuff, you build a bigger feature first, because you don't want to get interrupted, you want to get stuff done. And with bigger increments, the lead time till you get a part of that feature live is actually increased, because you never deploy parts of it. Because it's not fun, it takes time, you want to optimize your work time. It's not even that you're lazy or anything, you want to optimize how you work, but actually you go in the wrong direction regarding that metric. And there's a second part that I believe was the ownership and the question. I already said about what about, for example, build tooling. If you don't have the chance to optimize your tooling, how do I even optimize for my lead time for changes? No chance. if I don't have the chance to decide how I want to solve my problem, because everything is set up around me, I have no autonomy to fix anything. I mean, no chance. Everything is set here. Let's go for the next metric, change failure rate, and why are they related? That's a metric often business people understand well because they see the bugs and they believe that that's because we are lazy or we are stupid. But if you have those arguments, it might help. Once ago, again, we start with the build time and the bigger increment argument that I already brought. If you always deploy huge features, obviously there's a higher chance of doing mistakes because it's super hard to deploy a huge feature without doing any mistakes somewhere. If you would have done it in small parts, you would have found the problem earlier, but at this point I probably sound like an agile coach, but yeah, that's how it is. Second part that I personally find more interesting is about how does ownership help you with a change failure rate. In a huge application, usually there's stuff going on that you don't understand. And if you don't understand it, you have no idea how it interferes with the stuff you're building. You hope that it doesn't break and that it does not interfere, but as you don't know it, there's always some unknown somewhere. If you would have more ownership, you would probably know your domain better. Like if it's a small service only doing one search, it's easier to understand the whole search and to know where to look for. Then if you have a huge application of this is the whole web shop, do everything and find everything that's somewhere. Yeah. By the way, I forgot one argument for the build time. I said it in the beginning, it's hard to work test-driven with that huge thing, so you probably will not work test-driven. And if you don't work test-driven, you usually have less code coverage or worse quality code coverage. That's what's happening. And if you do, because usually what you're doing then is, I write my feature, then I have to write a few tests afterwards, but those are not the most helpful ones, only the things I thought about. That's the reality. So it's harder to find problems because you have worse tests. Not meaning less tests, but worse tests. You wrote them afterwards usually. And now we go for the last part here, the time to restore a service after you screwed it up, or after the system screwed it up. Doesn't have to be you. Once again, 3 parts. It's always build and deploy time first, but this is the obvious one. Now, if it takes you half a day to deploy your code and you want to fix the urgent problem, it will take you half a day to deploy that fix. So there is a correlation. That's more or less the obvious one. If you go for the scalability, actually. Okay, now my animation is broken. I want to go for the ownership part first. If you go for, if you properly own the application, if you really understand what's going on, usually you monitor your application. Because now you are interested and now you understand what you want to monitor. For monoliths, it's how the hell shall I monitor everything that's going on somewhere? And if I do, I have so many graphs that I don't know what to look at. But if it's a smaller thing, it's easier to properly monitor. And if you're really good at it, you even monitor business metrics, so you probably see if there's a problem faster. And that will help you to fix the problem faster because you actually find out. Because this time to restore a service is not how long does it take you to run a deployment, it is how long does it take you to find out you have a problem plus to fix it. So having more code ownership helps you to find the problem earlier, first of all. The last thing on that graph is scalability. I did that talk 2 months ago, and I said, okay, I don't believe scalability is important in this. Because, yeah, okay, scaling up takes longer because applications take longer to scale up, but I don't believe it's important. What happened? I went to the hotel after the talk, and the first call I got was, oh yeah, we have a production incident. Yeah, okay, why? High load, because of advertisement in TV? Yeah, okay, and nobody notified us? Yeah, okay, scale up more instances? Yeah, impossible, it's the monolith, it takes half an hour. In half an hour, the TV ad is gone. So actually, this can be a problem. I learned it half a day after the last talk. So, I've worked through all the correlations, and I hope at least one or two of them were also something that you have seen or witnessed and that might be helpful for you. I defined the goal I want to go to on that graph. We hopefully find one or two arguments how to get there, and now or why to get there. And now the question would be how to get there. There are multiple books on how to destroy a monolith, so I don't want to start on that fully. I just want to help with one business view on it that might be interesting, and that is, if you rewrite a whole monolith, that is fucking expensive. It takes you months to years, and it's hard to get arguments for it, but there's a different approach, and that's the final quote by Martin Fowler, and that's once again helpful. Try to cut small, you're cutting small, so start with something small and reasonable. And this is about the Strangler fig pattern, and yeah. The most important reason to consider a Strangler fig application over a cut-over rewrite is reduced risk, meaning business risk, not technical risk. A Strangler fig can give value steadily, and the frequent releases allow you to monitor its progress more carefully. What is a Strangler fig pattern? It means you start by taking out a very small part out of your application and connect it to the old world for everything else. Then you take out another very small part that already brings value, that is already used by customers. And then if it works, fine. Then you take out another small part, and over time you have so many parts taken out that the old monolithic application is more or less useless, and at some point you only have the leftover work of killing it, but there's no real value in it anymore anyways. Why do I want to go for that part? Because every single part has business value, and it's way easier to convince people. If you have some value in every single part, then yeah, please give me 5 teams for 2 years and you don't get anything done. I don't believe that you can manage that argument, but I would like to rewrite this first part because it's the right direction, and I have this and that argument that it will be especially helpful for that part. I only need this one team to work on it for 1 or 2 months. That might work. If it worked, you have a good argument to continue. If it didn't, it was 2 months, and you at least didn't spend so much money that the company is bankrupt now. So that's an approach I would always recommend to do. I brought one example of how we did it at Mr. Specs, just a small one to give you an idea. So what we are is a web shop, having a few applications, domains in it, meaning like something like we have products, we have users, something like a web shop, all fine. And what we did is the first part, we cut out the search, because the search was especially slow and bad. So that's something you can argue for. The arguments we used were actually 3. It was the page is slow, SEO is awful, and it takes us forever to deploy stuff on it. So one of the DORA metrics. How did we do it? First of all, we cut out the front end, because that's already bringing value to all 3 arguments. It took more than a month, yeah, but less than a year, so it went in that direction. Second part, if you did that, once again, the arguments were, it's still slow because the backend is slow. We're still using the old monolithic backend, so we still have to increase the page speed. We actually didn't work on the search quality, so now we have to improve the search quality in the backend. And we still want to go faster with new features like better search or new filters or whatever, so now we have to work on the backend. This was really a project of like 3 weeks. And I need 3 weeks and 1 team to replace something. Wasn't too hard to convince people to do that. How did we do it in that case? Like, give us 1 week, we want to try out if it works. If it doesn't, you can tell us to stop and never ask for it again. It worked good enough, so they said, okay, continue, bring it to production. And if you are in such a situation, I would always recommend like this. Can you find something where you say, give us 1 or 2 weeks or 3 weeks to prove if it works at all? Because then it is less risky. If it doesn't, you probably have a problem to ask for it again, yes, but at least overall nothing really bad happened. And coming to the end of this talk, I still wanted to bring something from the Accelerate book that I perceive as interesting, because also from the book, it's not about one ideal solution. There is no one ideal solution. The important part is trying to get in the right direction, and the right direction might actually change. So what they stated is the most important characteristic of high-performing teams is that they are never satisfied. They always strive to get better. I mean, you are in this talk, so you actually are probably interested in improving something. So obviously, you strive to get better and to improve the business. So here we go. It's already the right direction. I hope to help you to get some arguments to convince more people to go in that direction and to get to our island. It's not really us against business people, because if we want to go to the island, we need to convince the whole crew. But sometimes we see the sharks first, so we have to start pointing at them and convince people and actually support business people not understanding the technical problems, so we can all go to the same boat, to the same island. Thank you. Now, up for questions. In case you don't have any questions now, I'm also available like for 1 more hour running around, or for examples to discuss. Any questions right now?
As well as all the benefits, we heard about the risks of microservices when they're intercoupled, like a distributed monolith. So maybe, is there a way to get some of these benefits that you described, but still keeping a monolith? Or, you know, maybe re-architecting the monolith, but without making it distributed necessarily. Like, I don't know, modules, getting ownership, getting all these other things without making it really distributed.
So first of all, thanks for the question. So I believe there are multiple questions in it. First of all, the first is is it really going into like microservices or more into a distributed monolith or something in the middle? You can use all the arguments in every direction. If you want to have a distributed monolith or something like a monolith, I also heard about that term, like modules in a single system, not really splitting the application, but having proper modules with proper boundaries. Some of the arguments work for part of it, yes. So if you only want to build proper modules but don't cut the applications, you still get more ownership. It's already an argument for a part of it, sure. So hard right now in my mind to bring for every argument if it works for every case, but this at least would work. And yeah, you don't always have to go for the full pass. If you only have if you look at those sharks and see, okay, 5 out of 4 out of 5, I don't have that problem at all. That's nothing I want to solve. Yeah, so then probably the whole path of getting to a microservice just because of that argument is not worth it. And it might be exactly the right way to say, I want to have a big bit of module to have more ownership, but not the whole thing, because it's right now not worth it. Yeah. That's also, by the way, why I started in the beginning with I'm not against monoliths at all, only if you have a problem with them. I'm also not against microservices if they solve your problem. I'm not even against serverless super mini nano functions if they solve your problem best. Yeah, so have a look at what's actually your problem. So I've just seen the sign that the time's up. If you have more questions, I'm still available. Thank you.